In this section, we're going to learn how to organize data, in particular with a categorical frequency distribution. For example, let's say a researcher played a mobile device game for 2 hours, and the objective of the game is to capture as many virtual characters as possible. The following table shows the list of characters captured after 2 hours of playing. The characters in this particular game are plastic, liquid, wheat, insect, and metal. Now, in this raw form, the data that we saw from the previous slide is not particularly useful. The data must be organized so that conclusions can be drawn from the data set. So we shall construct what's known as a categorical frequency distribution, which is a table that utilizes classes and frequencies to organize the data. So our first step will be to make a table with the following headings: class, tally, frequency, and percent. In the class column, this column right here, we will place the categories. In this case, it is the type of characters that were captured in the game. Now, let's go back to the table and count the number of characters in each category. When we go back, you will see that there were 9 plastic characters, 7 wheat, 12 insect, 2 metal, 5 liquid. There were 9 plastic, and then we proceed with wheat, insect, metal, liquid in the same way. Next for wheat, we see that we have 7 wheat. Now I invite you to pause the video here and try to fill out the rest of this table accordingly. Doing this yourself, you should end up with 12 for insect, 2 for metal, and 5 for liquid. Step 3, record the frequencies. The frequency column simply places a number that were based on the tally marks from the previous column. So since there were 9 plastic characters, we simply put the number 9 in the frequency column. 7 for wheat, 12 for insect, 2 for metal, 5 for liquid. Last but not least, we now calculate percent. Now there were a total of 35 items in the table. And so what we will do for each percent is take the frequency divided by the total number, then multiply by 100%. Keep in mind that you can also write these frequencies as a decimal as opposed to a percent, depending on the problem. For this first one with plastic, we see that if we take 9 divided by 35, then multiply it by 100%, we get 26%. And just for future reference, this also is the same thing as 0.26, again, depending on the problem. Next, for wheat, we still divide by 35, but now we use 7 divided by 35, once again times 100%, and you get 20%. I invite you now to pause the video and please calculate for insect, metal, and liquid yourself and see if you get the same numbers as I do. For insect, percentage is 34. For metal, percentage is 6. And for liquid, we get 14%. We can now more easily see the distribution of the categories in the data set. For instance, the insect category was most popular with 34%. So as you can see, where an original table of values gave us almost no information, categorical frequency distribution can give us a little bit more information and help us move forward with a specific type of problem. Later on in your student notes, you will see that we will discuss group frequency distribution. A grouped frequency distribution is a useful tool that organizes a dataset in such a way that allows a reader to draw conclusions about said dataset. This is used especially when the dataset is large. Some attributes of an appropriately drawn group frequency distribution are as follows. 1. You must have between 5 and 20 classes. 2. It is preferable but not absolutely necessary that the class width be an odd number. We will discuss class width in a moment. 3. The classes must be mutually exclusive. 4. The classes must be continuous, meaning there should be no breaks between classes. 5. Classes must be exhaustive, meaning that all dataset must be covered from the classes. And 6. The classes must be equal in width. Now here's an example of a typical grouped frequency distribution. Now this is showing the ages of students in a community-sponsored art class. Notice that we have students in age ranging from 10 years old up to 39 years old. Also notice that each class of students is continuous. So we have 10 to 14, and then immediately we go into 14 to 19, then 20 to 24, 25 to 29, 30 to 34, and then finally 35 to 39. This lesson will discuss also how to set up what are known as class boundaries. In particular, you'll notice that in this case, we add 0.5 and subtract 0.5 to each of the limits in the previous column. And finally, the frequency indicates how many students are in each class. For example, there are 10 students that range in ages from 10 to 14. There are 18 students that range in ages from 15 to 19. There are 22 students ranging in ages from 20 to 24. There are 23 students ranging in ages from 25 to 29. There are 17 students ranging in ages from 30 to 34. And finally, 8 students ranging in ages from 35 to 39. Now, let's go ahead and follow along with your student notes. As always, make sure you fill out the blanks and let me know if you have any questions. Organize data using a frequency distribution. When we first collect data, it is raw data, which is unorganized and rather messy. In many ways, collecting raw data is almost useless. But when organized in a frequency distribution, we now can utilize the information more appropriately. Typically, a researcher will want to organize the dataset into a distribution showing classes and frequencies. Each data value is in a category called a class. The frequency of a class is the number of data values in that specific class, just like the previous example. So let's do an example. In this example, suppose we collected the ages of the top 50 wealthiest people in the United States from a recent Forbes article. At first, this raw data is hard to decipher and almost useless. However, if we organize this data in a frequency distribution, we'll find that we can make simple conclusions based on these numbers. For quantitative values like ages, the classes must meet the following criteria. 1. Have equal width. 2. Include values between the highest and lowest, called the range. And 3 have values in, at least, the first and last class as well. Let's keep in mind that the classes will never overlap. Once you understand that these are the 3 criteria for the classes that we must establish, we are now ready to select the number of classes desired. Now, usually this is up to you, meaning that you can select however many classes you wish for a particular problem. And you will get better and better at choosing a proper number as you practice. We also need to pick the beginning value. How do we do this? Well, looking at your data, which you should have in front of you on your student notes, you'll notice that 32 is the smallest value on this table. So I am going to go ahead and begin with the number 30. Notice how 30 is just below the smallest value in the table. This is done on purpose. And 30 is going to be known as our first lower class limit. The range is next. How do we find the range? It's essentially the largest number minus the smallest number. Therefore, the range in this case is 98 minus 32, which gives us 66. Now, if you recall, it is your decision on how many classes you wish to select. So it's always best to pick a number that will give you a nice full number if possible. So clearly, the number 6 is great because 6 goes into 66 evenly. Therefore, our class width for 6 classes must be larger than 66 divided by 6, which is 11. Once again, this is done on purpose. We will use 12 as our class width. We want to make sure that each class more than covers the numbers or data values that we need to properly place our data values in a frequency distribution. And so, as mentioned before, our first class begins at 30. And how do we construct any subsequent class? You construct subsequent classes by adding 12, the length of a class width. So if our first class begins at 30, our second class will begin at 42, because I simply added 12 to the 30. And we will continue in this manner until we get to the last class. Next class, 42 plus 12, 54. Fourth class, 66. Add 12 to 66, fifth class, 78. Sixth class, 90. And lastly, to add one more class, a seventh class would begin at 102, which is larger than any of the data. So we will end it there. And also notice that 102 is greater than 98, so we have all of our data covered. Notice that my class limits are from 30 to 41, then 42 to 53, then 54 to 65, and so on. This is done on purpose so that we can cover every number in the range and clearly tally based on the number of data values in the table. Now you have the data in front of you on your student notes, but to remind us, let's go ahead and take a look at how many tally marks are going to fall in this first class limit of 30 to 41. Looking at all the data values very carefully, we see that 32 is the only number that falls in this category. So we will simply put one tally mark in that box. For the next category, 42 to 53, looking carefully through all the data, we see that we have 10 that fall into that category. Now I invite you to pause the video here and try to tally mark properly the remaining class categories. Now hopefully you paused the video and went ahead and filled out the rest of this table yourself. And my hope is that you saw that in the next category we had 13 tally marks there. In the category of 66 to 77, we had 15. 78 to 89, we had 9. And finally, 90 to 101, we had 2. And quite simply, after you find the tally marks for frequency, all you need to do is place the appropriate number in the respective category. And that is known as a frequency, meaning how frequently does data appear in the table based on these categories. Now, data can be placed into categories such as nominal and ordinal data, which can be organized also using a frequency distribution. For example, blood type. Let's say we had 25 Army inductees who were given a blood test to determine their blood type. And the following is our data set. So we have blood types A, B, AB, and O. Now, since this data is already on your note sheet, keep an eye on this data as I continue. The data here is known as categorical, specifically discrete classes, meaning there is one category for each blood group. The last example was not discrete. Why do you think that is? And the quick answer is the last group was numerical, whereas here we have data that is clearly not numerical. Now, as a reminder, let's talk about how we create a frequency table. We have already done this a few times in this lesson, so these steps should be very familiar to you. First, make a table showing class, frequency, and percentage. So at this time, I'm going to add one extra thing to our table, the percentage. But you saw this in the first example in this video. Step 2, count the frequency of each category. Use tally marks if needed. You don't have to make tally marks, but many times tally marks make things easier to count. Next, find percentage. And we find the percentage of the values in each class by dividing the frequency of each class by the total number of the values. Step 4, find the totals for each column. So once again, as you can see on the left side, I have my class, which is placing our blood types in A, B, O, and type AB. Again, you have the data in front of you on your note sheet, but to remind us, let's go ahead and take a look at how many people had blood type A. And we see we have a total of 5. Now notice here, I do not have a column for tally marks. You simply can go straight in and write the number 5. Now what would be the percent? The percent would be 5 out of 25, and then multiply that by 100%. 5 out of 25 is 0.2. 0.2 times 100 will give us 20%. For blood type B, we have 7, which gives us 28%. I invite you to pause the video here and please fill out the rest of this table. There were 9 folks who had blood type O, which gives us 36%. 4 folks who had blood type AB, which is 16%. And again, our grand total were 25 inductees, which obviously means the full 100%. One thing to notice, if you were to add up all these percentages, the 20, 28, 36, and 16, it should certainly add up to 100. Much like if you were to add up the frequencies, it should always add up to the total number, in this case, inductees. Grouped frequency distributions. Now, what happens when the range of quantitative data is quite large? If you have a large set of data, then the data should be grouped into classes. It will be up to you to decide how many classes to use. There should be between 5 and 20 classes. Any less than 5 can be problematic, just as any more than 20 could also be problematic. So try to keep your classes between 5 and 20. And once again, please make sure that your classes do not overlap and that you pick a number of classes that is convenient for you. The lower class limit, again, is the smallest data value that can be included in the class. Thus, the first lower class limit must be no larger than the smallest value in the data set. Also, find the upper class limit for each class. This is the largest value that can be included in each class. Next, we find class boundaries. Class boundaries are the numbers used to separate classes. The size of the gap between the classes is the difference between the upper class limit of one class and the lower class limit of the next class. The class boundary is the midpoint of the upper class limit of one class and the lower class limit of the next class. Now, if the data values are whole numbers, find the boundaries by subtracting 0.5 from the lower class limit and adding 0.5 to the upper class limit. Once again, subtract 0.5 from the lower class limit, add 0.5 to the upper class limit. Please only do this if the data values are whole numbers. So again, if the data values are whole numbers, take the lower class limit and subtract 0.5. That will give you what's known as your lower class boundary. Also, take your upper class limit, add 0.5, and that will be known as your upper class boundary. But what if the data values are in tenths? Well, for this, we will actually go ahead and subtract and add as well in a very similar fashion, but this time we will subtract 0.05 from the lower class limit and add 0.05 to the upper class limit. Again, do this if your data values are in tenths. Class widths and class midpoints. Now we have some experience with class widths already in this lesson, so let me go ahead and take it a bit further. A class width is the difference between the lower class limit of one class and the lower class limit of the next class. In the previous example, our class width was 12, meaning our first class went from 30 up to 42, and you'll notice that we cut it off at 41. But the class width remained the same, from 30 to 42. Now, it is generally preferable that the class width be an odd number. That wasn't the case in the last example, but you will see as we progress through the semester that it will be generally preferable to have an odd number as a class width. The class midpoint is the average of the lower and upper class limits. The midpoint is the numeric location of the center of the class. And I will show a few examples in a moment. One quick example is if I have a lower limit of 24 and an upper limit of 30, then the midpoint is quantity 24 plus 30. After you add those up, divide by 2, then you get 27, which is the midpoint between 24 and 30. So before we get into an example, let's go ahead and look at the steps in order to construct a grouped frequency distribution. First, there should be between 5 and 20 classes, as mentioned before. Second, it is preferable, but not necessary, to have a class width that is an odd number. 3, classes do not overlap, so no data value can be in 2 classes, meaning you will not overcount. Classes are continuous. 5, there must be enough classes to accommodate all data values. Like the previous example, the youngest, wealthiest person in the United States was 32. The oldest was 98. You'll notice in that previous example, our lowest limit was 30 and our upper limit was 102. Number 6, class widths are equal. So for an example, below are listed the salaries of college and university coaches in hundreds of thousands. Let's construct a frequency distribution for the data using 8 classes. Now here, they actually let you know how many classes they want, which is nice. But typically, you are asked to find the number of classes yourself. First things first, we're going to go ahead and find the range. Recall that the range is the highest number minus the lowest number. Now the highest number in this list, if we look carefully, is $857,000. Whereas the lowest number in this list is $140,000. So finding our range is quite simple. 857 minus 140 gives us 717. Next, what we need to do is determine our class width by choosing, say, 8 classes. Again, they gave us this. Let's pretend like we chose it ourselves, but clearly it's nice when the example instructs you to find the class width on a specified number of classes. So what we're going to do is we're going to take the range and divide it by 8. That is to say, 717 divided by 8 gives us 89.625. Now, once the class width is established, you also want to make things easier on yourself by simply rounding up in this case. So our class widths will be a width of 90. With this information, we can now start to construct our frequency distribution table. But let me go ahead and list the items that we need in order to accomplish this. If I go a little too fast in my list, please remember that you are always welcome to pause the video, go back, and read my list again. Not to mention, these same items can be found in your student notes as you follow along. So now that we have our class width, let's now find the class limits. Next, we will find class boundaries. After that, we will find the midpoint of each class, followed by the frequencies for each class. And once these are found, compute cumulative frequencies showing the frequency of values less than or equal to the upper class boundary of a specific class. Also, we will compute relative frequency, which you have done before, so this should not be too difficult. which is the quotient of the class frequency and the number of data values total. This time, we're going to list the result in decimal form as opposed to percentage. Next, we will compute the cumulative relative frequency, which is the quotient of cumulative frequency of the specific class and the total number of data values for each class. So let us begin. The first class limit, remember, begins with our smallest data value, which in this case will be 140. To get to the next class limit, we need to add 90 as mentioned earlier. Our class widths have a width of 90. So take this 140, add 90 to it, and I get 230. And you'll notice I'm writing on the left-hand side of each of these boxes. So 230 plus 90 is 320. Add another 90, I get 410. 500. 590. 680. 770. And the reason why I'm writing on the left-hand side of each box, because we must also establish a range within each class. For example, since the first one starts with 140, the range will go all the way up to 229. That way, it does not overlap with the next limit. Following the same routine, 230 will go all the way up to 319, so it doesn't overlap with 320, and so on. Now I invite you to pause the video and please try to fill out the rest of this table, and you should end up with the same numbers that I have. Now you'll notice that this last one ends at 859, because if I were to have another class after this, it would clearly be 860. We don't have that, so we ended at 859. Next, we move on to class boundary. Now remember, if the items are whole numbers, we need to add and subtract 0.5 accordingly, meaning I need to subtract 0.5 from 140, then add 0.5 to 229. And you will see in future lessons why this is useful. For now, follow my lead. And we end up getting 140 minus 0.5 is 139.5, up to 229.5. Now you'll notice that the next class boundary starts at 229.5 again. This is because I am subtracting 0.5 from 230. But you'll notice it happens to coincide with the previous upper limit class boundary. This is no mistake. And you will notice this pattern throughout the table. That means the next lower limit will be 319.5 on up to 409.5. And once again, I invite you to pause the video here and get the same numbers as me. As a side note, remember, If our data values were in tenths, we would add 0.05 and subtract 0.05. But hopefully for whole numbers here, it makes sense. For the next category, class midpoint. What we will do here is take the upper limit and the lower limit of each class and divide by 2. So simply what I do is I add 140 plus 229, divide that by 2, and you end up with 184.5. Next, we add 230 plus 313, divide those by 2 to give us 274.5. And this one to me is fairly simple, so I invite you at this point to pause the video and try to get the same numbers as I do. And there you have our class midpoints. Now for frequency, being that there's a lot of numbers here, you have to look very carefully to make sure that you get the proper numbers in the proper boxes. So to remind ourselves, let's take a look at the salaries of the coaches. And let's ask ourselves, how many have a salary that belong in the first class? Meaning from 140 to 229. In particular, you might notice that my boundary starts at 139.5. And the reason for this is that at 139.5, it easily includes the salary of 140. Moving along, our first category is 140 to 229. That gives us the following salaries, of which I count 11. Scrolling back up, I'll put 11 in the first class limit. Now at this point, since we have done so many of these, I believe we can pause the video here, refer to your table of data on your student notes, and go ahead and fill in the rest of these frequencies. Adding up these numbers, we should end up with 30. It should make sense. Next on the list is my cumulative frequency. And all that simply does is it takes the frequencies from the previous column and adds them up as we progress. What I mean is, in the first class limit, we simply remain at 11 coaches. In the next cumulative frequency, we end up with coaches that actually not only receive at least 140,000, but also earn up to 319,000. So essentially, I'll be adding up the 11 and the 5, which gives me 16. Next, adding up the 11, the 5, and the 4, I get 20. One more time, adding up the 11, the 5, the 4, and then the next 4 gives me 24. Following the same pattern, again, I invite you to fill out the rest of this column, and you should end up with the following numbers. Here, there's no need to place a total in that bottom column there because we've already reached to the 30. Now for relative frequency, we have done this before, so I'll continue here with the same process. Recall that we are not going to use percentages, we're just going to use decimals. And all we simply need to do is take the number of coaches in each class and divide by 30. And what I get is 0.36, where the 6 repeats forever. So I'm going to put a bar over the 6. In the next category, for the coaches that make between 230,000 and 319,000, we have 5 coaches. So for that, I'm going to take 5, divide by 30, which gives me 0.16. Again, the 6 repeats forever. Put a bar over the 6. Now at this point, I do believe we have had enough practice, so I invite you to pause the video and go ahead and fill out the rest of these. Once you have filled all these out, you'll notice that if you add up all these frequencies, you should end up with 1. Now the cumulative relative frequency is similar to the cumulative frequency, where we are going to add up subsequent frequencies to get cumulative frequencies. And this time, we're going to use the decimals to do so. So my first cumulative relative frequency will be 0.36, where I put a bar over the 6. The second cumulative relative frequency adds up the first 2 decimals, in which I get 0.53. The third cumulative relative frequency adds up the first 3 decimals, for which I get 0.66. Once again, I invite you to pause the video here and go ahead and fill out the rest of these numbers. Hopefully you got the same numbers as me. Zooming out, here's the full table, which concludes our lesson.